Hi dear students, and welcome to this video tutorial. This is a question from the Southwest Regional Mock Paper 2 Pure Mathematics 2024 on polynomials. And the question reads thus: given that the zeros of a polynomial x cubed minus 2x squared minus x minus 2b are a, b, and a plus b, determine the values of a and b. Now I'm going to present the solutions in the form of a video, so pay close attention, and if at the end of the video you have some questions or you have some doubt, then just leave them in the comment section. I will make sure that I'll read them and I will answer to all the comments that has been dropped below. Then to begin with, we need to ask ourselves the basic question: what is the meaning of the zero of a polynomial? That is the question. Now, the zero of a polynomial are those values that if you plug them back into the polynomial, your answer will be 0. As easy. So it means if a, b, and a plus b are the zeros, then substituting these values into the function f of x, then it will give you 0. Now, what else does that tell us? It tells us that if a, b, and a plus b are the zeros of the function, then x minus a, x minus b, and x minus a plus b are factors of that polynomial. So these terms would divide the polynomial without a remainder. And since the degree of this polynomial is 3, it means if I multiply out these linear terms, I will have the same degree as the degree of this polynomial, which is 3. So what else does that tell us? It tells us that the product of these linear factors is going to give you this polynomial. So the idea or the way forward to solve the problem is to expand out all these linear terms to have a polynomial with the same degree as what was given to us. Then we compare their coefficients. Then from there we will have a simultaneous equation to solve where we can obtain the values of a and b. Now what we have to do first is to multiply this linear term by this linear term. Then when I multiply these two terms, I will obtain a quadratic term. Then I will take the quadratic term and multiply it again into this linear term to obtain a cubic expression. Then I compare the terms with this original expression in order to obtain values of a, b, and c. Now let me start by multiplying out the bracket. So I'll start with x times x squared, x times negative b bx, negative x times negative a times x, negative ax, negative a times negative b, positive ab. Now I have expanded the first two brackets. Now notice that these two terms, the term in negative bx and negative ax, are like terms because they are terms containing x. I can bring these terms together by factoring out negative x. So in the next step, I'll factor out negative x from these two terms, and I'll obtain negative a plus b multiplied by x, because negative is common to these two terms and x as well is common to these two terms. So I factor out negative x, then to obtain a plus b. You could still write it as b plus a. It doesn't change the fact, but it's better to write it in the order in which they appear in the alphabet, so that everything will be consistent all through your solution. Now, then I will after bringing the terms together, I will take this quadratic expression and I multiply it into this linear expression. So let's do the multiplication. X squared times x gives me x cubed. X squared times negative a plus b gives me negative a plus b x squared. Now negative a plus b into x multiplied by x is negative a plus b x squared. Then negative a plus b times x multiplied by negative a plus b gives positive a plus b all that squared multiplied by x. Then finally, let me take the term ab and distribute it across these two terms. AB times x gives, of course, ABX. AB times negative into A plus B gives negative AB into A plus B. Now again, we are going to observe that these two terms are like terms because they are terms in x squared. So we can just bring their coefficients together. So negative A plus B minus A plus B will give me negative 2 times of A plus B. So I will just replace these two terms by negative 2 into A plus B multiplied by x squared. Now I'll also move on and I'll notice that these are terms in x because x is common to these two terms. So I can as well factor out x from these terms, and I'll be having x as a factor. I'll be left with A plus B squared. Then I'll add it to AB. So I factor out that term. Then this constant term will just be there as is. There's nothing to be done with it. Now I've expanded completely and I've brought like terms together. What is left to do now is to take this and then compare it with the coefficient of this original expression in order to obtain the values of A and B. Now let's move on by replacing f of x by that original function that was given to us. So we are comparing x cubed minus 2x squared minus x minus 2b with what we just expanded. Now notice that here we are going to compare terms. So we are going to equate corresponding coefficients of x squared, coefficients of x, and the constant term. So it will not make a lot of sense equating the coefficient of x cubed to the coefficient of x squared because the answer is obvious. The coefficient of x cubed on the left hand side is 1 and the coefficient of x cubed on the right hand side is also 1. So it makes no sense equating that. So I will instead equate the coefficient of x squared on the left hand side, which is negative 2, with the coefficient of x squared on the right hand side, which is negative 2, into A plus B. Then I also equate the coefficient of x on the left hand side, which is negative 1, by the coefficient of x on the right hand side, which is A plus B squared, then plus AB. Then finally, I'll equate the constant term on the right hand side, which is negative AB into A plus B, to the constant term on the left hand side, which is just negative 2b. So I have this. What I'm left to do is that I will not expand the bracket because notice that I have all of these terms have A plus B. So it makes sense that let me solve it the way it is so that I can easily substitute to eliminate A plus B. Now I can simplify this first equation further by dividing both sides by negative 2. So when I do like that, I will be left with A plus B is equals to 1. Then this equation will just be there as is. Let me call that equation 2. And this one is just the way it is. Then this is the third equation. Now, A plus B is equals to 1. I'll take A plus B in equation 1 and I'll substitute it in these two equations in order to eliminate A plus B. Remember, I told you that it's not good to expand because if you multiply out the bracket, it will complicate your work further because the terms are like, they are similar in all the three equations. So I will take equation 1 and plug it into these two equations in order to eliminate and simplify the two equations further. So putting that into equation 2 and 3, I have 1 squared, of course, is 1. Then plus AB gives negative 1. Then next, I substitute it here. I have negative AB into 1 gives negative 2B. Then this 1 can be taken to the right hand side and I'll be having negative 1 minus 1. So AB is equals to negative 2. Let me call that equation 4. And then negative AB into 1 is equals to negative 2B. So when I multiply negative AB by 1, it gives me negative AB. So I'll be having negative AB is equals to negative 2B. This is equation 5. Now, these two equations becomes very simple to solve it because in equation 5, notice that B is common on both sides of the equation. So if I divide the left hand side by B and the right hand side by B, and not just B, negative B, then negative cancels out from both sides and B cancels out as well. So I'll be having, so when I divide it, I will see that negative b cancels out from both sides and a gives me a value of 2. Now I'll take this 2 and I'll plug it into equation 4. So I'll replace a by 2. So I'll be having 2b is equals to negative 2 and b is equals to negative 1. So this is the values of a and b. So I can both write a is 2 and b is negative 1. So just for the sake of understanding, I'll move on and I'll try to verify if these answers are right. But before we verify, let me go back to f of x and replace b with negative 1. So I'll be having negative 2 times negative 1. That gives me positive 2. So f of x, or this function, will now be x cubed minus 2x squared minus x plus 2. So this is the function now. Let me verify if in fact ab and a plus b are the zeros of this polynomial. So let me start. A is 2. Let me check if 2 is in fact a zero of today's particular polynomial. So I plug into 2 cubed minus 2 into 2 squared minus 2 plus 2. Then when I do the maths, it gives me 0. Yep, this term is supposed to be negative, so it gives me 0. It's verified. So this is supposed to be negative. So it gives me 0 and it's verified. So the next thing to do is that let me try with b as negative 1 and obtain f of negative 1. So substituting negative 1 all through in the function f of x will give me negative 1 minus 2 plus 1 plus 2, and this takes care of each other and gives me 0 is verified. Now let me take a and add it to b and plug it into that function if it will give me 0. So a plus b will be 2 plus negative 1, which is 1. So let me evaluate f of 1 to check if it is 0, and of course it gives me 0. So this is to tell us that all this work was not for nothing. So I hope at least you have understood one or two things. But if you have some doubt or complaints, then just drop them in the comment section. I'll make sure that I will come and glance through all the comments, and I will reply to the most comment as I can. Thanks for watching, and I'll see you next time.